So here's the first thing. You know how to use the properties of equality. This is the getting started, the very next page. So getting started, next page. You know how to use the properties of equality to solve equations in these forms. Okay? Does anyone know what forms we are looking at in these four?
Nope.
Those are all different vertex forms, right? Notice this is the most complete vertex form, but let's say you don't have a value for D, then you would just be left with this equation, or if D is 0. So that's still vertex form. Let's say you don't have a value for A is 1, this would still be vertex form. And let's say that you just have the Y value, the Y-intercept, then, or the Y value of the vertex, then you'd have this form. And you know how to solve these equations. We're going to talk about that for a second before we get into this lesson. And so it says use properties of equality. So I'm going to talk through one of these with you. I'm not going to start with A. I do want you to do A on your own. I'm not going to do D because I want you to work through that one. Let's look at C. I'm going to write that over here. It says the properties of equality. What do they mean when they say properties of equality?
The things that make it equal.
Anybody know?
The things that make it equal.
Okay, so say that, explain that a little bit more thoroughly, or if someone wants to add on to that, do say that. But what do you mean with the things that make it equal?
I was just guessing.
Oh, okay. Anybody else?
What did it do? The things that never mind. That was pretty stupid.
You didn't even say it, and also
Yeah, as soon
mistakes
as
are
I
good.
say it, I thought in my head and I was like, that's pretty stupid.
I mean, you might have been on the right path, but I don't know. Okay, so let me ask this then. If I'm looking, or if you're looking at this equation on the board, what would you do to solve this equation right now? When you say PEMDAS, what do you mean?
Order of operations.
Order of operations. Now, don't forget PEMDAS, that order of operations is to simplify, right? Parentheses. Can I do x minus 1 right now?
No.
Well, if I can't do x minus 1,
Answer the street.
okay, now be careful. You say distribute, right? But you're distributing the multiplication, right? But I would have to do the exponent first. So, well, say that one more time, AJ. What were you thinking? X squared minus 1 squared. Now be careful though. This is something we talked about. Actually, I think you were gone this day, so definitely pay attention to this. Does anyone remember we talked directly about this? It cannot be x squared minus 1 squared. Why?
You can't subtract the next one or something like that.
You said.
You gotta add, but you said you gotta do it another time.
You just
I
try
don't know
to
why. I
No,
don't know
it's
why.
a different.
Hold on, let's listen to what Smile's saying. What are you saying, Smile?
It's like x1, x minus 1, and then another x minus 1.
Remember, to square something means we have to do x minus 1 times x minus 1. And how would I multiply these?
No, he said don't ever say that. He said don't ever say that.
Don't-
Last
Hey, we're not going to call it foiling. It is called distribution. So x times x,
X for
x squared. X times negative 1,
negative X.
so minus 1x or minus x. Minus negative 1 times x,
Minus X.
minus x again. Negative 1 times negative 1, plus 1. And so notice, AJ, this has x squared, and it has the 1, but if you just do that, you're completely missing this middle term here. So you cannot just square the x and square the 1. Distribution only works with which operations? There's only two.
Quadratic and then.
That's not operations. Multiplication and division. Please listen carefully to that, because a lot of students mess that up. The only time that distribution works is with multiplication and division. If you don't have that operation, you can't do it. So I can't distribute the square. There's later operations we'll study with trig operations. We'll study square roots. We'll study logarithms. You cannot distribute with anything other than multiplication or division. Now I want to point out, at this point, I could distribute that 3, sure, but anybody know how to solve this equation from here?
Hold on. Minus 3.
That's standard form equal to 48. Okay, I could subtract 3, but then I get
That's-
45
That's good.
equals 3x squared minus 6x. Have you ever solved an equation where it's got x squared and x together like that?
Oh, yeah, to get rid of the
'Cause they
square.
not,
You have to
they not like.
root
So some of us might think we need a what?
Square root.
Okay, maybe take a square root, but whatever I do to one side of the equation, I have to do to the other side. I need y'all to pay attention to this again. Hold on, listen. Can I distribute that square root? Or do I need to take the square root of this whole thing?
Take the square root out.
Can you take the square root of that x squared and x at the same time?
No.
So we can't do that. So none of this will work. I'll go ahead and tell you this. I'm working this out so that you'll see it. This is not what you'd want to do. Go back to the beginning.
So what you did all that for me?
I just wrote all that for no reason, man.
Sorry. You could, actually it's not a bad thing to make a note instead of erasing, hey, this method doesn't work.
Well, it's gone now.
I'm sorry. So take notes on how we could do this. All right, one thing I'm going to do is I'm going to leave a little space here. And I want you to pay attention to this.
The reciprocal?
Can I use the reciprocal there?
Why you doing like this?
Well, because what is 3 divided by 3? So can I multiply by 1/3? Yeah. So I'm using an inverse operation, but remember we talked about this earlier. What I do to one side of the equation, do you know what the proper name for that?
Properties of equality?
Right. The properties of equality are what I do to one side of the equation, I have to do to the other. And it's not because it makes them equal, it makes those equations, it's another E word, equivalent. So the properties of equality are that idea that if I change the right-hand side, I got to change the left-hand side by the same amount. Notice 3 divided by 3 is 1. Does that make this equation easier to handle? Did I hear someone asking a question?
Yeah.
I just couldn't tell what you were saying, asking. Well, what's happening between the 3 and the parentheses? Right. Does that make sense now? I mean, what's the inverse of multiplication? Division, right? So remember, if we're trying to solve this, I'm trying to create zeros and ones. You're creating a 1 anytime it's multiplication and division. So times 1/3, I use that reciprocal.
And when you're adding, you make it 0?
When you're adding and subtracting, you want to make zeros.
So we can, right?
Yes. Anybody have an idea what I can do now?
Order of operations.
The same thing we did last time? X1, X minus 1, X minus 1.
I mean, but again, when we got to that point, regardless, like, we would have 16 equals x squared minus 2x plus 1. Do you know how to solve that equation?
No.
No,
It's in standard form.
Say it again, Kai. Say it louder. Well, we're not going to square root what's inside the parentheses, but can I square root the right-hand side?
Yeah.
What's the inverse of a square?
Square root.
A square root.
So you need square root, so it just be x minus 1.
Well, don't you have to square root 16 too?
And so I'd have to take the square root of 16 as well. So the square root of that square would give me what?
X minus 1.
It would give me an x minus 1, but I do want you to remember we're trying to create what kinds of numbers?
Ones and
Ones
zeros.
and-
Ones and zeros, right? When you do the square root of a square, it doesn't just make it x minus 1, it creates an exponent of 1. We're still trying to create zeros and ones. But x minus 1 to the first is just x minus 1. Okay? So what is it equal to? Tori, you have a question about that?
Oh, no, I saw.
Okay. Yes, Elijah.
X equals 5.
Huh?
X equals 5.
That's in front of the parentheses. It's a mark right here. Yeah.
This?
No, the one before that. Yeah.
The square root
What's
and
that
the
number?
square, that's a square root.
It's not enough.
It's just, oh, you marking out the square root?
Yeah.
Oh, okay,
The square root is canceling the square out.
okay. I just-
Right.
What about 16?
Yeah, what's square root of 16?
4.
Sure about that?
X equals 5.
4 times
Oh, negative 4.
16, right?
Negative 4 and 4.
Say that again, Key Anthony.
Negative 4 and 4. But
What I have, right, is x minus 1 squared is equal to 16. And I'm algebraically showing this, but I want you to just think logically for a second. Is 4 squared equal to 16?
yes.
Yes.
And negative.
Can I square anything else to get 16?
Negative 4.
Negative 4. When you take a square root you are always going to get two answers.
So which one were you?
Both.
How'd you say it?
Hold on, listen.
Twice?
Listen to me very clearly on this. Most of the time, how many roots were there of quadratic functions? 2. So how many answers are we supposed to get? 2.
Wait, is this something in the
This is
roots when you're talking
algebraically how we're going to get the roots. Oh. This is algebraically how we're going to get our roots here. So remember how I talked about we couldn't get those x-intercepts yet? We're learning how to do it today. Okay? So, not only does 4 equal x minus 1, but also,
Negative 4.
I got a question. Is there a way like to put the plus above, like right above the subtraction sign, to, like that?
this is how I honestly would write it out, personally.
Is that saying positive 4 and negative 4?
Yeah.
X minus 1 is equal to a positive and negative 4. So those are just two different notations. If you don't like that notation, don't use it. You can use this. Regardless, what am I going to do at this point?
Solve for us.
So add 1 to create a 0, add 1 to create a 0, and add 1. So yes, 5 is equal to x, but what else?
Negative 3.
Negative 3 is equal to x.
Oh, everything we did.
And those are x.
I know.
I
Uh-huh.
just don't remember.
I know. Alright, so I need y'all to look over here though. If you want to use this notation, you can. Again, I would add 1 and add 1. Notice that would give me 1 plus or minus 4 is equal to x. Hey, what's 1 plus 4? What's 1 minus 4?
Negative 3.
Negative 3. Does it give me the same answer? Not just pretty much.
He does.
It definitely does, okay? So, please note and make a note to yourself. You need to bold, you need to box, you need to put like fireworks around it, I don't care. You need to pay attention to that idea of the properties of equality. The main thing here to recognize about the properties of equality is what you do to one side of the equation, you gotta do to the other. Why is that? So I'm going to talk about two things with this. One, what you do to one side of the equation do to the other, and why is that?
So you get the right
Make them
answer
equivalent.
equal.
To make them equivalent.
To make
To make each side of the
the equations equivalent. It's not just about, no, we have learned, we're not focusing on how smart we are learning things well, but it's one of those things that we're not just trying to get a right answer. The way we get a right answer is by creating equivalent equations, due to the other, to create equivalent equations. That is a primary thing that we have got to recognize. And I want y'all to pay attention to this. Y'all wait a second until you get that note written down.
Next said she don't make her turn
I don't recommend that.
equal.
I don't recommend that one. You do what you want, but I wouldn't do it. Okay. Listen, hey, and I want y'all to pay attention to this at this point. Do you see this black equation, 48 equals 3 times x minus 1 squared? Does that look different than this brown equation, 16 equals x minus 1 squared?
Yeah.
Yes, but they're equivalent. Is that what you're trying to say?
That's the whole point of the properties of equality. These equations may look different, but because I use the property of equality, they are equivalent to each other. They look different, but they are telling the same story. This brown equation, does that look different than 4 equals x minus 1 and negative 4 equals x minus 1?
No, I mean, well, you know the math.
Yeah.
Right, but the whole point is, those don't look identical. But are they the same?
Yes.
Yes, because we used a properties of equality. Now, here's an important thing that we need to note as our last detail. How do we know which property of equality to use?
Does it depend on the multiplication or
Yeah.
division?
So you need to use the
Reciprocal.
Not always the
The
reciprocal.
inverse operation.
The inverse. Yes, Madison?
So is it like as simple as like, for example, I'm like, hey, it actually be like 6, you know, like that's like common sense, you know what I'm saying?
Is 6 the only answer?
No, you said it's 2 answers,
Well,
right?
there's two.
There's gotta be 2 roots determined by the
It's not just negative.
inverse. Please note, I'm adding an extra detail here, right? The second point, right, the second part of the properties of equality is that the property of equality is determined by the inverse. The property of equality that you're going to use is determined by the inverse. I was multiplying by 1/3, or by 3, so I multiplied by 1/3 and I had to do it to both sides. I was squaring, so I took a square root, and so I had to do it to both sides. You're trying to create those zeros and ones, and that determines what property of equality you're going to use. Now, Madison just said that 6 is a solution to part A. Hold on a second. 6 is a solution to part A. How could we check to see if that is true?
Substitute.
We can substitute that in, right?
Right.
27, does that equal 6 squared minus 9?
36 minus 9.
Did you know that you can quickly actually check this on the calculator?
Yeah, it's gonna say true or false.
It's going to tell you true or false, and it's going to tell you true, okay? So 6, x does equal 6. But you're now thinking maybe a negative 6?
Yeah.
Now I want to caution you. Is it always just a positive and a negative of the same number?
No.
No, so it depends on, and that's why you would want to work the problem out using those inverses. So let's check it. Type that negative 6 squared minus 9 into the calculator. Does it tell us true or false?
I have a question, how did you get 6?
We'll talk about that in a second. She just knew.
Did somebody just say false?
Yeah.
Mine say false.
Mr. Kenny? Why is it false?
Yeah, it's just well, because we got
Well, I know, like, if you
so
square it,
it's
you can make it allowed.
Listen, it's because, and this is the mistake that a lot of you are going to make, that I did not write it correctly on the board. Your calculator understands the order of operations. Technically, what this is saying right here is 6 squared, and then the opposite of that.
We didn't put parentheses.
You need to put parentheses around it. Try it again with parentheses around that negative 6.
So that's right.
It's true.
So like,
True this time around?
yeah.
Okay. So be careful with that.
These are
So
all
it's in the calculator.
every single one.
No, it's
Not necessarily. Here's the only time, well, first off, I will point this out. It depends on the type of quadratic. Remember, we just talked about the fact that these solutions tie into what idea that we studied.
Property.
The what form,
inverse.
well, it ties into the idea of factored form, and how many roots were there in factored form? 2. However, if I have this parabola, does that have 2 x-intercepts?
No.
Not 0. It has 1. So how many roots would you have in that case?
1.
1. If I were to have this parabola, how many roots does that have?
That's 9.
Does it ever intersect the x-axis?
Never mind.
No. So in this case, there would be none, or at least no real roots. And we're going to get into the imaginary number system a little bit and talk about it there. But does that make sense, Madison?
Yeah, that
So
makes sense.
technically, there will always be 2 in different ways, okay?
So parentheses matter.
All right, yes, the parentheses do matter, but also, okay, hold on, guys, we still got 3 minutes left. I don't know why you think you're packing that book up.
Hey, how you know I'm doing it?
You literally have it closed and then trying to go to your backpack.
Okay.
So let's look at this mathematically together. I'm going to leave, yeah, because you have a homework assignment for tonight anyways, but
Man.
We got one to do now.
I got practice.
Ain't
Are you gonna send an email?
I'm not going
about
to give
that?
you any more. I'm saying I'm not going to give you D for homework.
Will you
Listen.
send an email out about that?
No, I'll put it up on the board at the end of class so you can take a picture. All right, so let's algebraically look at how we can get 6 and negative 6. So what would I do to solve this equation? Use that inverse, add 9, creating a 0. So then 36 is equal to x squared.
Square root 36.
Square root, well, actually be careful, this is the whole point. I'm square rooting the square, but I have to use a property of equality.
How you do that?
What?
You just Xing out.
Well, it's not just xing out. Square roots and squares are inverses,
So it's just
and so I'm creating an exponent of 1. And x to the first is x. But because I took a square root, how many solutions?
2.
Plus and minus 6. Okay? So when I transition over here to B, what am I going to do? Square root, right? So that's the very first inverse or operation I need to take the inverse of. And again, that's an exponent of 1. So I get x plus 3 to the first, or just x plus 3 is equal to?
11.
Oh.
Sure, it's just 11?
Plus 11.
You've got to remember when you take that square root, it's a plus or minus 11. So now what can I do?
Subtract 3 to make a 0.
Well, be careful. Subtract 3 to make a 0, and then do it on both sides. Now, can you have made this two different equations?
Plus or minus 8.
Yes. So I get it's not plus or minus 8. That's why you need to be careful.
How?
Because what's negative 3 plus 11?
No, but you. I thought
Listen,
you was
this is my
supposed to
question.
add 3. I mean, subtract 3 from
That's
that.
8.
I did. Listen. What's negative 3 plus 11?
8.
8. What is negative 3 minus 11?
I don't know.
Negative 14. You cannot assume. You need to pay attention and actually do the operations. It will not always be the same. All right. So here is the homework assignment. I definitely do feel like this is true, that there's been some good learning today, but don't forget, what are all of you? Capable of, don't you dare say that, Elijah. 4. So here is the practice, the homework assignment. I can guarantee you that we have done practice problems like this. You can look at lesson 4, for example. You can also look at the practice assignments that we have done in class over the last couple days. Have a great rest of your day. Look forward to seeing you all tomorrow to learn more about solving quadratic equations. See you, Hudson.
Okay, this the